Salam, peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holophase. Part 22 Novelty Generation Rules. Why the story doesn't just loop forever. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once: time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. You're standing at the summit of Book 9.5, Computational Generation, in Episode 9. Our ascent through this book has been a journey into the mechanistic heart of the generative grammar. We saw phi as a programming language, the universe as a cellular automaton, and we marveled at how algorithmic information theory shows that simple seeds can generate worlds of immense complexity. But a final, haunting question remains, a question that pierces to the core of our experience of a living, surprising, evolving cosmos. If the universe is a deterministic computation following fixed rules from a simple starting point, why is it not boring? Why doesn't it just settle into a repetitive loop, a fixed pattern, a never-changing equilibrium? Why do we see perpetual novelty, new stars being born, new species evolving, new thoughts being thought, new patterns in every cloud and every snowflake? Where in this rule-bound computational universe does genuine newness come from? Today, in Part 22, Novelty Generation Rules, we reach the crowning insight of computational generation. We discover that the holophase grammar is not just a complexity amplifier. It is a novelty engine. It contains within its very structure the precise mechanisms that ensure the story never just loops forever, that it continuously produces patterns that have never appeared before in exactly that way. Our anchor image is a fast-flowing rocky mountain river. Watch it for an hour. The water obeys the simple, fixed laws of fluid dynamics. The rocks are fixed. Yet, the pattern of the water surface, the exact arrangement of whirlpools, eddies, whitecaps, and swirling foam, is never the same from one moment to the next. It is perpetually new. You could watch it for a lifetime and never see the exact same configuration repeated. The novelty is not magic. It is generated by the nonlinear interaction of the water with itself and the rocks, by its sensitive dependence on every tiny ripple and gust of wind. The river is a novelty generator. The universe is this river, flowing through the rocky landscape of its own laws. Here is the profound human puzzle of this part. We live in a universe of constant surprise, yet our physics seems deterministic and rule-bound. How can a system that is, in principle, predictable from its initial state and laws, produce outcomes that feel, and in a deep sense are, unpredictable and new? Is novelty just an illusion, a product of our ignorance? Or is there a genuine physical production of newness written into the grammar itself? The answer is that novelty is real, and it emerges from specific, well-understood features of dynamical systems, features that are built into the holophase grammar. Let's name the three great engines of novelty. 1. Nonlinear interactions. As we've learned, nonlinearity means waves and fields don't just pass through each other. They mix, scatter, and create new modes. This is a source of combinatorial novelty. Two simple wave sentences can interact to produce a third, entirely new sentence that wasn't present before. In a linear world, you only hear the instruments playing their own parts. In a nonlinear world, you also hear the chords, the harmonies, the beats, the new musical entities created by their interaction. 2. Sensitivity to initial conditions, chaos. This is the famous butterfly effect. In many nonlinear systems, two starting conditions that are infinitesimally close will, over time, diverge exponentially, leading to completely different outcomes. The technical measure of this is the Lyapunov exponent. A positive Lyapunov exponent means chaos. This sensitivity means that any unmeasurably small detail, the quantum fluctuation of a single atom, the distant flap of a butterfly's wing, gets amplified to macroscopic significance over time. Because we can never know the initial state with infinite precision, the long-term future becomes fundamentally unpredictable, even in principle, from within the system. The system is constantly making choices based on microscopic noise, generating a unique, never-to-be-repeated trajectory. 3. Branching at instabilities, bifurcations. As a parameter of a system changes, like temperature, energy, or density, it can reach a critical point where the current stable state becomes unstable. At this bifurcation, the system must choose between new possible stable states. Think of a ball balanced perfectly on the peak of a ridge. A tiny push sends it rolling down one side or the other. The choice is sensitive to infinitesimal fluctuations. Each new branch represents a new type of order, a new chapter in the story. The evolution of the universe is punctuated by such bifurcations: the formation of forces after the Big Bang, the phase transitions that created matter, the emergence of life. These three engines work together within the phi field. A nonlinear equation, from the action, governs the field. It has regimes of chaotic sensitivity. And as the overall conditions of the universe change, it expands, cools. The system passes through instabilities that open up new branches of possibility. The phi rules mix modes, amplify noise, and fork paths, ensuring that the story is not a predetermined tape being played, but a genuinely exploratory, path-dependent computation that is always writing its next line based on its immediate, noisy past. So here is the point. The universe is not a clockwork that repeats. It is a chaotic, exploratory computation. Its determinism is global and retrospective. The entire history is a single computation. But its phenomenology is local and prospective. The next moment is genuinely contingent on unknowable details. The novelty is not an illusion. It is the hallmark of a nonlinear, chaotic, bifurcating system. The Holophase grammar is specifically designed to produce it. Let's explore the tri-unity of novelty generation, the time echo of novelty, the arrow of surprise. Time is the dimension along which history accumulates. The time echo is the perpetual unveiling of the unprecedented. Because of chaos, you can never step into the same river twice. The exact microstate never recurs. Because of bifurcations, time carries the system through qualitatively new regimes: ice ages, evolutionary epochs, cultural eras. Time is not just a sequence, it is a narrative of irreversible, path-dependent discovery. The space echo of novelty, the uniqueness of place. At any given moment, novelty is distributed across space. No two snowflakes are alike because each follows a unique, chaotic path through the phase space of crystal growth in a turbulent cloud. No two galaxies have exactly the same structure because each formed from a unique set of initial density fluctuations amplified by gravitational instability. The space echo is this patchwork of unique instances. Every locale is a unique output of the universal novelty generator. The motion echo of novelty, unpredictable trajectories. The motion of things, the path of a storm, the fluctuation of the stock market, the evolution of an ecosystem, is not just mechanical translation. It is an exploratory trajectory through a landscape of possibilities. The motion is not merely implementing a plan, it is discovering a path in real time, sensitive to countless tiny perturbations. The motion echo is contingent history in action. Now let's locate this exhilarating concept on the master tree. We are at the Novelty Generation branch, the highest, most dynamic limb of Book 9.5 Computational Generation. This branch depends on the previous nodes: nonlinearity from dynamical grammar, the computational perspective, and the understanding of information production. It enables the transition to the next grand book, Book 9.6, Hierarchical Generation, because novelty is often organized into stable new levels of structure: new species, new social institutions, new physical phases. It also provides the final answer to the challenge of determinism versus free will within a physical framework. The universe is deterministic, but creatively exploratory, and our minds are subsystems participating in that open-ended exploration. To make the generation of novelty tangible, let's illuminate our understanding with lanterns from science and life. Near lantern, from everyday experience. The weather. The equations of fluid dynamics and thermodynamics that govern the atmosphere are known. They are deterministic and nonlinear. Yet, weather forecasting is famously limited to about 2 weeks. Why? Because the atmosphere is a chaotic system with a positive Lyapunov exponent. Tiny errors in measuring the current state, the temperature over an ocean, the humidity in a forest, grow exponentially, rendering long-term detailed prediction impossible. This is not a failure of science. It is a feature of the system's novelty generation. Every weather pattern is genuinely new, a unique product of the planet's chaotic atmospheric dynamics. The clouds outside your window right now have never existed in exactly that configuration before, and never will again. A middle lantern from biology. Evolutionary adaptation and speciation. The rules here are genetic inheritance, mutation, and natural selection. The initial conditions are a population's gene pool. Mutation provides the microscopic noise, analogous to thermal fluctuations. Natural selection is a nonlinear filter that amplifies some variations and suppresses others. Environmental changes act as bifurcation parameters. When a population becomes isolated or the climate shifts, it can branch into new species, a novel form of life that never existed before. The entire breathtaking diversity of life is the output of this billion-year-long novelty generation process operating on the simple substrate of DNA and chemistry. A far lantern from astrophysics, the formation of planetary systems. A star forms from a collapsing cloud of gas and dust. This cloud is not uniform. It has tiny random density fluctuations, the initial condition noise. The laws of gravity and fluid dynamics are the nonlinear rules. The collapse is chaotic and sensitive to these initial fluctuations. The result is a unique planetary system. The number, sizes, orbits, and compositions of the planets are a novel outcome of that particular collapse. Our solar system, with its specific arrangement of planets, is a one-time, never-to-be-repeated novelty generated by the cosmic rules. Another star system will have a different, equally novel configuration. From the ever-changing sky to the tree of life to the uniqueness of solar systems, a universal truth blazes forth. Fixed rules plus microscopic noise plus nonlinear amplification plus branching instabilities equal endless, authentic novelty. The universe is not a recording, it is a live performance. What then is the specific language role of novelty generation rules? They are the grammatical guarantees of an open-ended narrative. They are the meta-rules embedded within the dynamical grammar that ensure the story is not just grammatical, but also creative, exploratory, and historically contingent. They answer the question, how does the language avoid getting stuck in a loop, and instead keep generating new, valid sentences forever? The core question this part asks about phi is, what are the specific features of the phi dynamics, nonlinearities, instabilities, chaos, that ensure the time evolution of the field produces perpetually novel configurations, and how can we measure and predict the rate and nature of this novelty production? We are moving from asking, what is the state, to asking, how inexhaustibly creative is the process? What do these novelty rules do in the generative process? They ensure the universe's history is non-repetitive and open-ended. They provide a physical basis for the emergence of genuine contingency and historical uniqueness. They explain the limits of prediction and the existence of stochasticity even in deterministic systems. They link the microscopic world, quantum fluctuations, to macroscopic novelty through amplification. Now, stability and breakdown. The theory of dynamical systems and chaos is mathematically rigorous. Novelty generation is a robust property of wide classes of nonlinear equations. It breaks down or is absent in integrable systems, special, often linear systems that are perfectly predictable and do not exhibit chaos. Much of classical physics, like the two-body Kepler problem, is integrable and predictable. The novelty comes from non-integrable, non-linear many-body systems. Three gravitating bodies already exhibit chaos, which are the norm in the complex universe. So the grammar contains both predictable and novelty-generating subsystems within it. This brings us to our empirical foundation, falsifiability. The claim that novelty arises from specific dynamical features of phi systems is a quantitative testable hypothesis. The central claim. For a physical system described by a holophase field phi, if the derived equations of motion are in a regime predicted to be chaotic, with positive Lyapunov exponents, or pattern-forming, with instabilities, then experiments must show 1. Sensitivity to initial conditions. Two nearly identical preparations must diverge exponentially over time, with a measured divergence rate matching the predicted Lyapunov exponent. 2. Novel pattern generation. The system must not settle into a simple repeating cycle, but must produce an endless variety of configurations whose statistical properties, like frequency spectra or correlation functions, match those predicted by the chaotic or turbulent phi model. A concrete measurement scene, a chaotic double pendulum. A double pendulum, a pendulum attached to the end of another pendulum, is a classic chaotic mechanical system. Its dynamics can be derived from an action for the two angles, which can be seen as components of a phi field in a simple configuration space. We set up two identical high-precision double pendulums side by side. We release them from almost exactly the same starting position. The difference is less than a millimeter in the initial angle of the top arm. We use high-speed cameras to track the angles of both pendulums over time. The pass condition, validation. Initially, the two pendulums swing in near-perfect synchrony, but after a few swings, they begin to visibly diverge. Soon, they're moving in completely different, seemingly random patterns. We plot the difference between their angles over time. The data shows an exponential increase in this difference. The slope of this increase on a semi-log plot is the measured Lyapunov exponent. This measured exponent matches the value predicted by the nonlinear equations of motion derived from the phi-based action for the pendulum. The motion of a single pendulum, while deterministic, is unpredictable in practice beyond a short time horizon and never repeats. It is perpetually novel. The experiment directly demonstrates chaos and novelty generation from simple deterministic rules. The fail condition. The two pendulums stay synchronized indefinitely, despite the tiny initial difference, or they diverge only linearly or not at all. Their motion quickly settles into a simple repeating limit cycle. The measured divergence rate is zero or negative, contradicting the prediction of chaos from the phi model. If a system like the double pendulum, which the phi grammar clearly classifies as chaotic and novelty-producing, instead behaves in a perfectly predictable, non-novel way, the link between the grammatical structure, nonlinear terms, and novelty would be broken. It would mean our understanding of how dynamics produce novelty is fundamentally flawed for that class of systems. This falsifiability ensures that our awe for the universe's creativity remains rooted in measurable, reproducible laboratory phenomena. Let's cultivate a practical recognition skill. You can train your perception to recognize novelty generation in any process where the same rules produce non-repeating, unpredictable outcomes, especially when small differences lead to large consequences. Watch a campfire. The laws of combustion and fluid flow are fixed, yet the dance of every flame, the shape of every ember, the path of every spark is unique and unrepeatable. The fire is a chaotic system, sensitive to air currents, fuel arrangement, and temperature gradients, producing endless novelty. Observe a conversation. The rules are grammar and social norms. The initial condition is the topic. The conversation unfolds through nonlinear feedback. Each statement influences the next. It is sensitive to tiny cues, a raised eyebrow, a tone of voice, and can branch into unexpected topics. No meaningful conversation is ever truly repeated. Consider the growth of a city. Zoning laws and economic forces are the rules. The original settlement is the seed. Growth is nonlinear, network effects, economies of agglomeration, and chaotic, sensitive to individual decisions, historical accidents. The resulting urban fabric, the unique layout of streets, neighborhoods, and landmarks, is a novel historical product that could not have been precisely predicted. Whenever you see a system that is alive with unrepeatable detail, where history matters and where prediction is inherently limited, you are witnessing novelty generation. You are seeing the universe's grammar writing a fresh sentence. We must connect this culminating insight deeply to our holophase journey. In the previous part, we saw how complexity is generated from simplicity. Now, we see that this is not a one-time production of a static complex object. It is a continuous, open-ended production of novelty. The universe is not a frozen complex sculpture. It is a fire, constantly consuming its own past to create new light and heat. The computational generation is not a calculation of a fixed answer. It is an endless, exploratory computation. If you want to see the full mathematical derivations and exact equations behind this idea, the analysis of stability and bifurcations, the calculation of Lyapunov exponents, the theory of strange attractors and turbulence, you can search for Holophase on Zenodo. There you will find the scientific papers that this audio journey is built on. Let us pause at this summit and survey the completed landscape of Book 9.5. We began by seeing the universe as a computer. We then explored its architecture, cellular automaton, its information generating power, algorithmic information, and now its ultimate creative feature, novelty generation. We have a complete computational understanding. The universe is a deterministic but non repeating, open ended computation that transforms a simple seed into an endless, surprising story. In the next part, we will step back and begin to organize this overwhelming novelty. We will enter Book 9.6, Hierarchical Generation. We will ask, how does this endless creative flux organize itself into stable, nested levels of structure? How do molecules emerge from atoms, cells from molecules, organisms from cells, societies from organisms? How does the grammar simplify when we zoom out, giving us effective laws at different scales? This will be the bridge from the fundamental, churning computation to the structured, multi-level reality we live in and study. Before we end, the mandatory zoom out to hold our scope. Novelty, chaos, bifurcations. These are all behaviors of the phi field under its dynamical rules. We have added no élan vital, no supernatural spark. We have simply recognized that the grammar we've been studying, with its nonlinearities and instabilities, has creativity built into its very logic. One field, phi, plus its infinite tower of derivative questions, plus the principle of stationary action, executing as a chaotic, bifurcating, open-ended computation. From this, all newness flows. As we conclude, hold the image of the mountain river. It is constrained by its banks, the laws of physics. It is driven by gravity, the principle of least action. But within those constraints, it is forever free, forever new. Every eddy is a unique thought in the water's mind. Every crashing wave is a punctuation mark in a story that never ends. We are that river. Our consciousness is one of its most intricate and self-aware whirlpools, feeling the current of time, sensing the rocks of circumstance, and marveling at the endless, novel beauty of the flow. The universe doesn't loop because its grammar is the grammar of a river, not a clock, and it is forever riding its way to the sea. Salam and peace be upon you.